welcome everyone to our, April 2022 Edmonton R user group meetup. Thanks for coming. We'll have the privilege to have Mike today, Michael Thomas, presenting about eCharts. So I give a bit of an intro, but I'm sure, Mike, you might give a bit more intro as well when you dive in. So Mike is a Shiny and R developer consultant based in Connecticut. Correct me if I'm wrong. And he has been doing a lot of Shiny development lately. And he's also a co-host of the, the R Weekly podcast, right? Is that right?
You got it. Yep, our weekly highlights.
And so he's tightly integrated into the Shiny community. He's doing a lot of volunteering there to kind of looking around and seeing what's hot and letting the community know. And today he's going to talk about one of his favorite tools in his arsenal, which is eCharts. That is a JavaScript visualization library. And of course, there's an R implementation, which works really nicely on its own as part of Shiny apps. And I'm not quite sure from all of you who joined tonight, how many have used or heard about Shiny? So Shiny is a web development framework from within R. So within R, you can just use R syntax and have a beautiful UI in no time that does something with your data. And this is where charts are going to be really useful. And so I don't waste any more time giving this intro. So Mike, it's all yours. Let me just allow you to share. Anyone has any questions so far? If not, then I'll let you introduce us to eCharts4r.
Sure. Could we take a quick poll? I don't know if there's like a poll button, but that'll help me gauge the talk and how in depth or how high level I should keep things. I don't know if you can just put in the chat yes or no whether you are familiar with Shiny.
Okay, I'll do a quick poll.
Okay. It's not a trick question, I promise.
Okay, I have this poll.
You must get the poll button as the host. Oh, there we go.
Yes. I just had to find where to launch it. So I think it's done. So 4 out of 9 said yes, okay, which means more people are not yet familiar with Shiny.
No, that's
not
okay.
Counting us. So
that's
the
helpful.
Audience, I mean.
Shiny's going to be at the very end, so this isn't a whole Shiny talk, but I am going to, I guess, sort of operate under the assumption that you're familiar with ggplot or even base plot plotting in the R language. So
yeah,
we're
going to
try
a safe bet.
Okay. We're going to try to take that to the next level and move from static plots like you would get in ggplot or just the base R plot function and actually get interactive visuals. And that's what we're going to demonstrate today in the eCharts package. So I will share my screen. I guess first for some context, again, Peter, thank you for the introduction. I'm the chief data scientist at a company here in the USA on the East Coast called Ketchbrook Analytics. We do what we call full stack end-to-end data science, which is all the way from data management to developing predictive models to building web applications so people can go in and slice and dice the data that they want to take a look at. And we do most of that in R. We do some Python as well, but we really, really love R. So we're excited to have the opportunity tonight to present at your R users group. And what we're going to be presenting, I'm assuming everybody can see my screen. Peter, thumbs up.
Yes.
Okay, awesome. Is this package called the eCharts4r package. And this was developed by a guy, I believe, out in France named John Kuhn, who's developed a lot of really, really cool packages in the R ecosystem. A lot of them do have to do with Shiny. So he has some packages for like having a nice loading screen while something's computing on the back end of your Shiny app or dashboard. And then he has this package as well, which I have really come to fall in love with, eCharts4r, which is an implementation of this JavaScript framework, which has nothing to do with R, an open source JavaScript visualization library called Apache eCharts. And that's sort of how this R package got its name, eCharts4r. That's the implementation of this, this open source JavaScript library. And if you go to the examples, if you just go to eCharts.apache.org, I can even throw all these links in the chat that I'm talking about if it is helpful. Let me see. If you go to eCharts.apache.org, you can see all of these different charts, examples that they have for you, like this basic area chart. And you can see that, you know, a lot of the functionality is in the tooltips, where you can hover over the chart. It's something that you can't do in ggplot, and you can you know, get some more information about exactly what you're hovering over or looking at. You have the ability to do things like subtract a particular item in the legend so that you can just see one component if you want. And when they redraw, you know, they redraw kind of across the screen like that in an animated fashion, which is pretty cool. And I think it's pretty self-explanatory as to how this builds on top of things that you might create statically in ggplot. It gives sort of a nicer user experience that might be more comparable to off-the-shelf tools like Power BI or Tableau or Looker or things like that, where the user has more ability to interact with the charts and the visuals that they're seeing on screen. So let's see. One thing that we have available as well is this cheat sheet in the eCharts4r library. I'll just kind of continue before we actually get into the R implementation. I'll continue with taking a look at the JavaScript, website here. But you have the ability to sort of look at all of the pieces by name of the chart that you want to hover over. So if I'm hovering over this particular portion of the chart, up in the right-hand side here, it'll tell me what that element is. So this is called the data zoom element. So when I need to reference this in my code and I want to change the color of that or the width of it or something like that, I know the name of that element. And this, if you're more interested in diving into sort of the JavaScript side of it, this cheat sheet might be a nice place to start as well. So this is a fairly new package, this R package. It was first on CRAN in, I think, late 2018. Most recent version was in January, version 0.4.3. And let's walk through maybe a little bit of the R code for creating some of these visualizations here. So let's see what we've got. Let's start with a bar chart first. So I'm going to quickly create a little data frame here based upon that iris data set that we all know and love. It is in the base R package. So we can take a look at exactly what this data frame that I'm just calling data looks like. This nice little table. It's just 3 observations of 2 variables here. We took the average of the sepal length column across the group, across the 3 different species. Maybe I'll blow my screen up. That's probably really small for everybody. if I can even go to 175. Okay. Oh, then I lost the ability to, I hate when that happens. I lost the ability to apply it and get out of that. Oh man. There we go. All right, let's apply that instead. Hit okay. Okay. Peter, is this still too small?
I think 150 will be fine.
Okay. Okay. So this becomes a really small data frame, just 3 rows across 2 different columns here that will plot 3 different bars on a bar chart, one for each species, and then the length of the bar will be sort of that mean sepal length. So one way that you might be familiar doing this in the past, if you have done this with interactive Plotly, actually, maybe we'll show how to do that in ggplot first. I'll get a little aggressive here and try to do this on the fly. Let's see if we can see how we would do this in ggplot. So we would do something like pass our data to ggplot with our AES of x equals species, right? Our y aesthetic would be the mean sepal length, and we might add a geom bar. All right. Let's see how this ends up. Stat count can only have a x or y aesthetic. This is what I get for trying to program on the fly. Did anybody spot the error, Peter? Stat count. It must be about stat equals identity. There we go.
There you go.
All right. So this is sort of your basic bar chart that you might get in ggplot. We have 1 bar for each of the 3 species, like I'm talking about. And this is static, right? You could spruce this up and add colors or change all sorts of different things on this. But as long as you're operating within ggplot, you're going to have a static plot. So one of the first interactive libraries that came out is this library called Plotly, which is open source as well. And it has implementations in both Python and R, which is really nice. There's also some closed source versions of this that give you some extra added benefits like corporate branding and things like that. But for most people, the open source works really well. And the syntax for this is sort of similar. You're setting your x and your y, what variable you want to use on your x-axis. You have to put a little tilde in front of it. And then we'll do the same thing for y, mean sepal length. And this is the data that we would have here. You know, the first argument of Plotly is data. Let me load the package first. First argument is data. I'm just piping that in using the base plot. This is equivalent to saying data equals data instead if I got rid of this first line. But I'm just kind of skipping that using the base pipe. And if I ran this code, you see this is a pretty concise piece of code, just 1 function here with 3 different arguments that we need to create this plot that looks very similar to what we just did in ggplot, right? But now we have the ability to actually hover over each bar in the chart, and we get some information in the tooltip, this little thing that appears when we hover over these different bars here. We also have this little toolbar on top that has a bunch of different options for us to download this plot as a PNG, which is nice functionality. To zoom in if we want to in the plot, I think we can sort of hover over, or we can drag our mouse you know, in a rectangular fashion, an area that we want to zoom in on. We can double click to zoom back out. So we do have you know, some of these nice options that appear when you hover over this plot. Personally, Peter, I don't know if you've used Plotly very much or if anybody else has used Plotly very often. I find myself hardly ever using or needing any of these tools above the chart from a user experience standpoint. If I'm, you know, building something like an app or putting this just in an HTML file so that somebody can take a look at this report and hover over it, they're probably potentially going to get confused if they're not familiar with Plotly about what all of these things are in this toolbar up at the top. So you take that for what it's worth. You know,
Yeah,
based upon
I usually exclude that as part of the options, but
Yep.
you can end up with some like more complex plots when that brushing feature might be needed. I mean, that's rare. So someone was asking about if there's going to be a GitHub version for this code, but I'm going to share whatever we end up using today. Then it's going to be in the like on the eCharts4r website.
Of anti-Semitism
Somebody's not on mute. So this is the GitHub repository. Okay, this is the GitHub repository. I just put in the chat for anybody that wants to go take a look at everything that we're looking at today. All this data is up in this GitHub repository.
Cool, thank you.
If that helps. Yeah, no problem. No problem. So we have, you know, a fairly nice, simple, quote unquote, interactive, because we're getting these tooltips, plot here that's fairly easy in a couple different lines of code. And we can do the same exact thing using this eCharts4r library instead. And we're going to try to mimic exactly what we saw in both of these previous two charts. We want this bar chart that's, you know, broken out by species, where the bar length is the mean sepal length. So this is actually going to require us to call 3 functions. The first function that you use, no matter what type of chart you're building in eCharts4r, is just called eCharts. And this is where you set your x-axis variable. So in our case, again, x-axis is going to be species. Then we're going to set the next function we're going to use is called e_bar. All of these functions in the eCharts4r package start with e_. So they have, you know, sort of a syntax that might be similar to other packages that you might have seen, like stringer, where every function kind of starts with the same prefix. That's the case in eCharts4r. So what we're going to set here is the series that we want to use for our y variable. And instead of y, the argument here is serie. So what we're going to have is mean sepal length again. And then if we want to add this tooltip on hover, that doesn't come out of the box. So if we just ran these 3 lines without that last function eTooltip, we'll get this interactive chart here, but we don't get any tooltip on the hover. So we actually have to turn that on. Instead of, if you were in Plotly, you would actually turn that off, because that does come out of the box for you. And there's a couple options for the tooltip. One is the axis trigger, and the other one, if you have something like a bar chart, we'll show the axis trigger. It makes more sense on line charts. If you have a bar chart where you kind of have this big area to select from that you want a tooltip to show up on, item works a little bit better. So we'll run this again, adding our tooltip this time. And we can see we get the same chart, but when we hover over it, we now have this tooltip. I personally think that this tooltip is a lot more aesthetically pleasing than the one that we saw 2 plots ago in Plotly. That just sort of has, you know, that little tag. I don't know. I guess it's personal preference, but I find it to be a lot more aesthetically pleasing, and I find it to be a lot more similar to some of those off-the-shelf tools that other people might be experienced with, like Power BI or Tableau or stuff like that, that are you know, a little bit more polished on how they do things like implement tooltips, but obviously not you know, sort of Turing complete, where we can code those up and use version control and all those nice things that we have as R developers here. So I just wanted to run through this little script on how to create a bar chart 3 ways. It was originally 2, but we pulled off the ggplot to give you some sort of context on the differences between ggplot, Plotly, which is probably the most popular, and eCharts4r, which I am trying to push as hard as I can for the latest and greatest in interactive visualization libraries for R. So I can pause there before I go on to the next example. I don't know if there's any questions that anybody has, or go ahead, Peter.
Yeah, just going to tease you. So can you show us ggplotly?
Yes, I can show you ggplotly. So if we go back up to our ggplot code, so ggplotly is a function that's exported out of the plotly library that does its best to turn a ggplot into a plotly plot, so something that's interactive. It makes a lot of guesses, I think assumptions about exactly how you want to format these particular things, as opposed to if you're sort of coding just using the plotly library, you have the ability to more formally specify all the different formatting things that you want to have happen. But if you just sort of want the fastest approach, that you don't care too much about the nitty-gritty formatting, I believe that you can just tack on, let's see, plotly, ggplotly to this. And if we run that again, so that, remember, we're building a ggplot that we're converting at the end into plotly. Let's see. I think we might actually have to create it as an R object first. So let's try doing this actually down here, so I'm not confusing people. Build a plotly chart with ggplotly. All right. So let's just copy this bar chart, and I can rerun this just so that we remember exactly what this looks like. That's just our kind of plain Jane ggplot. I'm going to save this as just an object called P. And then I think if I do ggplotly P, we might have better luck. So let's try this again. I don't know why that is the case, but that it's working now. So it looks almost exactly like what we saw when we just did this out of the box plotly. I think we get blue bars when we ran this plotly code, as opposed to our gray bars, because it's literally sort of just adding the base elements, which right now is the tooltip and all these different elements that we have for zooming and panning and things like that to our ggplot that we just created. So a pretty quick way to get most of the functionality that you want from plotly just tacked onto your ggplot. If you don't care too much about formatting additional things on top of this, this might be all that you need.
Thank you.
You're welcome. Okay. Anything else? Or want me to keep going? We can move on to building a line chart and some of the additional functionality that you get from eCharts4r that I really like as well. Okay. So let's pretend that we want to create a chart. Again, with Iris, we want to show the petal widths as like a time series on a line chart. Pretend that the observations in the Iris data set were collected over time. So we're going to run some boilerplate code that you don't have to care about too much to create this data set that we can take a look at that we'll be able to chart on a line chart. So this is the new data set that we're going to work with. We have a list of dates. We have the petal width collected at that date and the particular species that we were dealing with at that date. So I think we're running from January 1st to something like February 19th for the first species. And then it starts over again January 1st for the next species, the versicolor species. So it looks like these were collected daily and 3 samples per day, 1 for each species. So this is a great use case to take a look at trend over time, potentially, considering that we have a time element to our data set, which calls for a line chart in our case. So one nice thing about the eCharts4r library is that you can actually specify a group by argument, like you would if you're familiar with using the dplyr package, to tell eCharts4r that there are some groups that we're passing, which will essentially show up in the legend, because we want to break out our chart by these 3 different groups, 1 for each species. And that would make sense to put that in a legend so that we have 3 lines across sort of the same x-axis, because these were collected along the same date interval. So again, we'll specify the eCharts, any eChart, the first function that it needs is the eCharts function, where we specify what we want along our x-axis. And because this is a time series line chart, what we're going to want along our x-axis is the date. what we're going to want for our lines themselves, the values of those lines, which we'd consider our Y, would be the, what do we have in this new data frame here? Petal width. And then for our tooltip, last time we used item. This time we're going to use axis, and we'll show how this tooltip is a little bit different than the last tooltip where we just hovered over the bar and got the value. So let's create this simple line chart using eCharts4r. Again, we get that kind of cool animation as the chart builds from left to right. And when we hover over the chart, now we have this vertical dashed line that is used. And that's all due to this trigger equals axis instead of trigger equals item. If we were to use trigger equals item, we would actually have to have our mouse hover over each particular point in order to get a value for that point. When we say trigger axis, we get this nice vertical dashed bar so that as we just move our mouse from left to right across the x-axis, it doesn't matter how high up or down our mouse is vertically, we'll still get the values for all three groups across all three lines. We have the ability to remove a line if we want to. Nice thing about this is that the plot is reactive as we interact with this legend. So the y-axis will grow or shrink depending on how much room it needs to show the different range of y values that we are working with. So really nice functionality in my opinion, really nice aesthetically to look at, just kind of using most of these base functions right out of the eCharts4r library. So if we take a look at that eLine, or this eLine function in particular, if we go into the help, we can see the different arguments that we might have to work with to do some customization on this line. Let's pretend that we wanted to, if we go back to this, instead of solid lines, let's pretend that we wanted those lines to be dashed or dotted or something like that. If we go to the help documentation for eLine, we see that we have a few different arguments here. We have the Siri, which we know is sort of that Y value. We have bind as the next argument, which is sort of a way to link two plots together. That's not what we're looking for. We have the name, which if we wanted to rename the values in our legend, we could pass a named argument there, which is just a string. Legend allows us to either show or hide the legend itself. So it doesn't look like we have any arguments that allow us to change the line type from a solid line to a dashed line, at least not in this eLine function. But the nice thing about this eCharts, Apache eCharts whole JavaScript ecosystem, which I will bring over here, is that there are pretty much hundreds of different ways that you can format these charts that aren't implemented sort of out of the box in R, in the R library, but are available for us to use with a little bit of extra code that I'm going to show here. So if we go to this type of a line chart here, if I expand this, this next one would be for bar charts, this next one would be for pie charts. So if we look at all the different formatting options that we have for line charts, we can see that, you know, for instance, if we go to the symbol, by default, the symbol for the legend is an empty circle. So we go back to this viewer, right, on our legend, it's an empty circle. On all of these dots on our plot, they're circles that aren't filled in. So that makes sense that that's sort of the default value, but maybe we want to fill that circle in instead. So what we would have here is actually just the symbol argument that we have access to in eCharts4r, even though it's not specified in the user documentation, because there are so many different arguments that would have to be specified, because we literally have, you know, at least 50 or 60 different formatting options. If we just look at every single one here, you know, the offset of the points, whether or not to show the symbols, which are the circles that we're looking at, all sorts of things for the legend, labels, all sorts of stuff. If you want to put data labels on your plots. So in our case, let's pretend maybe that we want to fill in our circles. So instead of an empty circle, we want to use one of these other options that we have here. So let's try to use the circle option. And we know that we can implement that by just using this argument name called symbol. So we'll say symbol equals circle. We're going to add this argument here. So this is the exact same. Maybe I could do it right here. It might make a little bit more sense. Symbol equals circle. And now instead of an empty circle, we have full circles. So this does rely on you if you want to take advantage of all of the formatting options that we have available from that eCharts JavaScript library. It does rely on a little bit of digging to go to that documentation of the eCharts JavaScript documentation and take a look at all of the different formatting options that you have access to. The nice thing that John has done for us is this additional arguments link right in the help documentation will take you right there. That's what I clicked to pop up this documentation where we were able to go and see what we had available. So we could do something like if we wanted to change the symbol size as well from 4, we could change it to 10. We could add that argument as well. So let's try that. Symbol size equals maybe 15 to make it really exaggerated here. If we rerun that, now we have giant filled in circle dots on our plot. So really nice to know that we have a pretty clean implementation within R of all of these different formatting options that we have access to across this eCharts JavaScript ecosystem. So I think that is pretty much what I have for sort of live coding. One thing I did want to show, which is maybe I'll show a couple more things first before I get to a Shiny app that has some pretty cool features to it. So some other things that I really like about this eCharts4r library that I will just sort of call out here is the ability to zoom. Let me see if I can find where exactly this is. Oh, so it is in the brush and slide. Okay. So you sort of have the ability to add these, what they call data zoom elements on either the X or the Y axis of your plot. So if you have a really long time series that you want to give users the ability to sort of hone in on just a particular section of that time series, you could give them this slider really simply by just adding this one function here called eDataZoom. And they have two, they've repeated it, one for the X axis and one for the Y axis. But this allows you to literally click and drag and shrink down that X axis to any sort of interval that you want to show. And you can do the same thing across the Y axis if for some reason you had data where it would make sense to do so. So that's one of my favorite little tricks that I like to use from a time series perspective. You know, when we were building some local COVID dashboards and that data, you know, we didn't think it was going to last that long, but that data has lasted a long time. So giving users the ability to have this data zoom underneath it so they can just look at maybe the more recent, you know, last couple months of that really, really long time series has been a really nice thing that we've been able to do in some of the Shiny dashboards that we've published for the public. Another thing that I really like is the ability to capture like mouse click or brush selection events. So if you go to, John has, the author of the eCharts4r package, has this really nice example, Shiny app that sort of walks you through a few different use cases of all the different functionality that the package has. And if you hover over a point on this chart, you'll notice that down here, we are getting values for the points that you hovered over. So what that means is that we have the ability to capture client-side events on the server, which is really cool because, you know, that sort of ties again itself to more off-the-shelf tools like Tableau or Power BI or things like that that have really strong ability to connect plots together, connect a plot and a table, things like that. So if we have the ability to capture, I'm going to click on this red circle here, and we can see that we have a clicked data point values as well. So if a user were to click on, one point in a chart and that were to filter another chart, that is something that I find super useful and sort of blows the minds of users from a user experience standpoint, that they now have the ability to do this and filter and slice and dice the data in all sorts of ways that they may never have thought they might be able to do. So we do have the abilities to capture these client-side events, which is really, really nice. We can connect two charts so that you can filter one chart by interacting with another chart as well. If we go down here and we have some of these tooltip options that look a little similar to what we were seeing in Plotly. If we grab this box select and decided that we just wanted to drag and select a few different points, we would see that this chart on the right now updates based upon the points that we are particularly selecting, because some of the data is shared across these two plots, which is really, really cool. Another one of my favorite features as well. And that all is taken care of, I believe, by, let's see, where it's a binding, I believe, or eBrush. Let's see. Yeah, it's this, I think it's enabled by this eBrush, which allows you to grab, sort of lasso these points that we want. And yeah, I think that's all we're looking for at this point in time. So I guess the last thing that I will show is a Shiny app that we built to sort of exemplify the way that you might tie interacting with a plot to filtering a data table underneath it. That's all of this is, again, is in that repository that's right on GitHub in the examples folder. So we're going to create a quick little data set here. I can show you what this looks like in the console. Maybe I'll just write this out really quickly. Somebody's going to have to remember for me to remove that little bit of code there. Oh, all right. This will be easier. It's already getting assigned. So this is the data that's going to end up in our heat map. It's the iris data set, but we just added another variable onto this data set that just samples from the letters A through F. So just randomly assigns a single letter, either A through F, across all of the 150 observations in the iris data set for this nice heat map that we're going to make. And I'll show you how that makes sense here in just a second. So maybe I'll show you the functionality first, and then we can walk through the code itself. So one thing I did want to also show is sort of the redrawing capability. So once you have a Shiny app, which is a web application that's written completely in our code, once you have an interactive Shiny application up, anytime that you make any changes to these charts, they have this really cool animation for redrawing. You can actually turn that off if you wanted to, but I like it. I think it's a pretty neat kind of trick that users really seem to like in the apps that we develop. So we have the ability to put this little input filter up here where we can select a particular species. We just want to take a look at one, or we can add, all three of them. And both of these charts will update and we get that nice animation. So I just wanted to show sort of what that animation looks like in an interactive setting. The last thing that I wanted to show is sort of how you would capture these click events on a chart and provide additional information to the user as well. So in something like a table, and this is something that we do all the time, if the data lends itself to building a heat map. So what we did is we took the sum of the petal width in that iris data set across this sort of crosstab of the species and that group variable that we just sort of made up with the letters A through F. So we summed all of the petal widths across all of those different combinations. I guess 3 times A through H is 6, 7, 8, 3 times 8. So 24 different combinations, right, that you could have. So we summed up all the petal widths in the data set. We have this nice little tooltip at each sort of cross section. So we're in group F across the x-axis. The species on the y-axis is versicolor. And the sum of all the petal widths that met those two conditions, group F and versicolor, was 7.4. We have this nice color gradient where the smaller values are yellow, lighter, and as they get darker towards red, the values increase. So this sum of petal width was 19.5, as opposed to down here, it was just 1 across group E and Setosa species. So this is aggregated data, right? Because I aggregated it across the group and the species combinations. We had 150 data points in our data set that we just looked at, but we only have 24 sort of cells here in this chart that we're looking at right now. So if I wanted to see, I know, okay, the sum of everything that was in group G and Virginica added up to 19.5, but what did those individual observations look like? I could click on this particular cell and I could get a nice table that shows up down here and shows me just the observations that were Virginica and group G. And it looks like there were 10 total that met that. So I can look at sort of the granular level of data to see exactly what these observations are. And if we summed up 2.5, 1.7, 1.8, 2.1, all the way through the last one, 1.8, that would hopefully add up to 19.5. I think we could do a better example. Let's see if we have some smaller data here. This is 1.0, group E and Setosa, just 5 observations here, 0.2, 0.2, 0.1, 0.3, 0.2. If my math checks out, that adds up to 1.0. So a pretty cool interactivity that we have on these click events. Every time I click a particular cell, this table down here gets updated. And if we just want to dive into the, I guess, nitty-gritty back-end code of how this works for a half of a second, I can show you what that looks like in the server side of this Shiny application. So that heat map data was already created. We already saw that. We group the data and do that summarization down here because that heat map data is that 150 observations, but we have to group it and summarize it by petal width for just get those 24 different observations that translate to the 24 cells that we saw in our heat map. So really, when we create this object called heat map, this output on the server side, eCharts4r sort of gives us for free this heat map underscore clicked data input. We have access to this automatically. I didn't have to create this. By creating that heat map output, we got this for free. So what I'm able to do is create this event reactive that says, okay, on this event, and what is that event? It's the clicked data event, specifically when that click happens. What do we want to do that we have access to that the client clicked on? So that gives us 2 values, specifically one for the x-axis value and one for the y-axis value. So we access those by input, heat map, click data. We have to tack on a $ value to that to be able to get at the values of that input. And then the 1 and the 2 reference the x-axis value, which was the group, so letter A through H, and the 2 would be for the y-axis value, and that would be the species. So we just created a nice little list output here of group and species. And then we have this variable, this reactive variable called selected, that will have access to downstream for when we create this table. So I use the reactable package. You could use the DT package or any really table R package that you would like to create our table output. What I did first was require that this click event has been created to even show this table in the first place. So that selected object has to exist. And then all I did was, because I created a list there, I have this reactive variable called selected. If you're familiar with Shiny, that you have to tack on to these reactives, open parentheses, to be able to access what's inside of them. And then I'm grabbing the group by just using the $ group here to grab whatever that value is. And then same with species here. And I'm filtering that heat map data such that just through dplyr filter, such that we only want observations where the group is whatever the group is that got selected in the heat map, and the species is whatever that got selected in this heat map for the species. And returning this table here up into the UI as sort of the last thing that we'll show in the UI, this reactable table output here. So that's sort of the under the hood at how that works. I think it's a really clean implementation of being able to grab these client-side events and use them in our server side. You know, all I really had to do was this little chunk of code to be able to grab those. And it's nice that really for free, we get this heat map click data input that we have access to. So thank you, John, for building that right into the package for us Shiny developers. So Peter, I think that's, to be honest, everything that I had to demo today on this. If there's any more questions, I'm happy to take some questions, or if not, I'll hand it back to you.
Thank you very much. This was really good. Just introduction where these interactive plots are coming from, and then ending up with Shiny, because I think that just Shiny has motivated a lot of these R libraries, because otherwise, like, why would you need it really if you don't have a way to share it? Like if you're just printing it out or putting it in a PDF, that's not really useful. And so I think where this is really coming from is that we had HTML version from R Markdown and more interactive versions through either Shiny or a combination of R Markdown and Shiny. And this really opened up the door to include everything that is JavaScript really and has to do something with data. Now you can have it in R. And luckily there are lots of really enthusiastic people who are willing to share their work online and making it available for the community. So thank you again for giving us this introduction. And the only thing that I just wanted to kind of highlight, you hit on a few keywords really, that interactivity and reactivity. So that always fascinated me, that one sentence description of the Shiny package has these 3 keywords in it. And that is just reactivity, interactivity, and responsibility. Responsiveness, maybe that's a better word.
Yep.
These mean slightly different things, at least in my mind. So when you have a responsive app, that means if you're looking at your phone versus a gigantic screen, it is still going to look nice, because if you have 3 columns, those are just going to reorganize depending on the aspect ratio or just the size of the screen. So that's responsibility, which is mostly a UI thing. Shiny developers don't really care about that. Interactivity is all what we've seen, right? If you hover above a bar chart and you want to see the exact value, that's what we mean. It's mostly a client-side thing. Everything is in your browser, and now all the data is there, and you just have the ability to go back and forth. When that action that you take is going to impact the data, because now you're looking at a different subset, that is what I think often we mean by reactivity. And maybe this heat map thing is kind of borderline between reactivity and interactivity. I'm not quite sure. But when you, for example, select, okay, give me now versicolor instead of the other species, that might be a trigger that is changing some state of the app. Now we have a reactive object that has different values in it. And that's a really key thing in Shiny, that it preserves the state of the application. So it is possible to go back and forth and do a lot of these iterations, how you explore apps or data. And this is, I think, pretty unique. There are lots of similar data related libraries that one can find, like Python has Dash and a lot of other things, but those are all stateless. So you really need to think hard about, if you want these events and you change them together, how to keep that state kind of together so that one part of the app knows about the other part of the app. And in Shiny, this is just really straightforward and it's handled by default. So that's the only thing I wanted to add, because I know some of the people in the audience are not as familiar with Shiny. So how this whole eCharts and Plotly thing fits into these buzzwords. Anyone else have any questions? Lionel.
Hi, I'm thinking that with publications, normally you would have a regular plot that you produced with the basic plot function, or maybe ggplot. I'm kind of wondering, have you heard of any like online journals? Is there a precedent for articles to like store some object that was created in, say, Plotly or eCharts4r as some kind of R data file, and then have that as a supplement or as a kind of interactive figure in a manuscript, as opposed to a regular kind of flat figure?
I can take that for a second, Peter. You might have more to say on this. It's been a while since I've been in academia, if we're going sort of down the academia side, but I can tell you that the New York Times is a journal here in the United States, and they are one of the leaders in interactive data visualization, and almost all of their online publications that they're doing nowadays have interactive visuals that either allow you to just hover over the chart and get some information like we saw in those tooltips, or actually sort of as you scroll down in the web page, things appear and disappear. A big library for all of the data journalists that I know is this thing called D3, which is this whole language in and of itself that most data journalists use nowadays. But I don't know necessarily about academic publishing. I know so much of that is sort of static, but because we're consuming that on the web for the most part, right, whether it be through archive or whatnot, we should have, the ability to be able to render these interactive plots where folks are consuming them, which is most of the time on the internet.
Yeah, my take on that would be, I think that's true that these traditional academic publishers are not really at the forefront of these innovations, but authors try to find innovative ways, especially if not all the data can be just shoved into an appendix, and you can find interesting ways to explore it, like through an interactive map or something like that. That's when people end up kind of putting together their own mini websites to kind of supplement what's in the paper. And I think that is an extra burden on the authors, but it is also a way to reach people who otherwise might not have access to a paywalled PDF.
I can see it being helpful. I keep coming back to the tooltip perspective, but if you're just looking at a bar chart and trying to line up the top of the bar with the y-axis and saying, oh, is that 5.6 or is it 5.7 or is it 5.5? You know what I mean? Sometimes if you're reading just a static publication, it's hard to know that exact value, and maybe it's important for you to know that exact value if all the data is not shoved into the appendix. Whereas if it were interactive, you might be able to get the ability to actually look a little deeper into what the underlying data is.
Interactive plots would certainly be more useful for analyzing, say, three-dimensional plots, where you might struggle to find just the right angle for the best view of the relationship. Instead, if you can actually almost if you had an interactive 3D plot, it's almost like you could pull it as a cube and then just look at each face to see where relationships change for different values of two predictor variables on the response. So I can see how these interactive plots would be useful for visualizing interactions in models.
Yeah, absolutely. That's a really good point. Bye, Fiona. Some people have to leave. Well, anyone else have any questions for Mike, or just in general about Shiny and how to go about these interactive maps? Or no, not really maps. We haven't covered maps, but just graphs is what I meant to say. Now is the time. Okay, if there are no questions, I think you can find Mike online on Twitter, and he's happy to answer any more questions that you might run into down the road. But I wanted to now take some time to kind of give you a glimpse of what's coming, either next week or next month, because we have some nice lineup of speakers, and there is actually a mini one-day workshop happening next week. So let me share my screen so that I'm not missing any of the details. So here in my browser, you can see a one-day workshop, which is happening on May 3rd, Alberta time, 10 to I think 3 p.m. with a lunch break. And so the whole point is we had Mauricio presenting to us about his work on analog.c.r package back in the fall. And so he submitted this workshop to the RStudio conference, I think in 2019, he delivered it, and in 2020, it was canceled due to COVID. So he had this all ready to go, and he was eager to present it to some folks. And that's why we kind of organized this as a meetup event. So if you are keen to learn about how to write an R package, which is really an internal R package for your organization to support your workflows, then you can find this on Meetup and RSVP there, and you'll get the link how to join and everything. So this is one of the upcoming events. And the next one is our next speaker is going to be in May. Ronnie Hernandez Mora is going to talk about website building with R for scientific and technical communication. So some of you might be familiar with some of these tools out there, how you can quickly just use pretty much Markdown or R Markdown and generate nice looking websites, and how to kind of use templates to make it as easy as possible. So he's going to talk about this at our May meetup. So if you are interested in any of these, either the workshop or this next upcoming talks, please RSVP and join us next time. Anybody else have some parting questions, comments?
I got to run it myself, Peter, but thank you so much for having me. And if anybody wants to reach out, I threw my LinkedIn in the chat, so I appreciate it.
Thanks so much for giving this talk to us.
Okay.
All right.
Take care. Have a good night, everyone.
Good night.